A dripping faucet wastes a cup of water. If it drips for 3 minutes, the amount of water wasted varies directly with the amount of time the faucet drips. How long will it take for the faucet to waste 4.5 cups of water? I'd say it's time to fix this faucet. That's quite a bit coming up. You can do this two ways. You could set up a proportion. If it wastes 1 cup for every 3 minutes, and the amount of water wasted varies directly with the amount of time the faucet drips. Remember, y varies directly with x. That's written in the form y equals kx. If the water wasted varies directly with the time, then remember each time you divide y by x, each time you divide the water wasted by the time, it's going to be the same thing. So you could set up a proportion. You could do 1 over 3 and set that equal to, says how long will it take for the faucet to waste 4.5 cups, set that equal to 4.5 over x. So water wasted over time equals water wasted over time. The amount of water wasted varies directly with the amount of time the faucet drips. Or you could do it this way, where you could find the constant of variation first. We'll say W equals the amount of water wasted, T equals the time. Water wasted varies directly with time, so W equals K times T, just like we've had Y equals KX. Y varies directly with X, water wasted varies directly with time. So if we substitute in out of that first sentence what we know, it's 1 cup every 3 minutes. That's going to give us the constant of variation, which is 1/3. It's wasting 1 cup every 3 minutes. And then we can apply that to this question. How long will it take for the faucet to waste 4.5 cups? We'll put 4.5 in for W, 1/3 in for K, and then you could solve that for T, which is what we'll do here. 4.5 in for W, 1/3 in for K, and then solve that for T. That's going to give us the time it takes to waste 4.5 cups. To divide by, or to solve for T there, divide each side by 1/3. That's the same as multiplying by 3. When you divide by a fraction, you multiply by the reciprocal. So if you multiply each side by 3, you'd have T equals 13.5 or 13.5 minutes. You'd get the same thing if you set up a proportion taking 1 over 3 and setting that equal to 4.5 over x, or in this case, T, if you wanted to use that. 13.5 minutes. Which equation of direct variation has 24 negative 8 as a solution? Remember, each time you divide y by x, it's going to be the same. That y divided by x is going to be the constant of variation. So you can do this a couple ways. Some people are going to just substitute in. That's going to be time consuming though. If you substitute y, negative 8 in for y and 24 in for x into each one of these, that's going to waste up some time. All you have to do is find the constant of variation. Divide negative 8 by 24. And that is going to be negative 1/3. So you're looking for the constant variation of negative 1/3. That's going to be this last one, y equals negative 1/3 x. You can check that. Put those values, the xy values back in. So put 24 in for x and negative 8 in for k. It should make a true statement. You can see it does. Letter I is the correct answer. Which equation does not represent a direct variation? So which of these cannot be written in the form of y equals k times x? In other words, which of these does not have a y-intercept of 0? Well, you may want to just go through and see if you can get each one of these in the form of y equals k times x. So if we start with this one, can we get this in the form of y equals kx? If you add 4x to each side, you can see that y equals 4x. That's direct variation. How about this one? If you cross multiplied, you would have 4y equals 3x, and then divide each side by 4, y equals 3/4 x. That's direct variation. This one here, if you added 4 to each side, that's going to be a problem. This one down here, if you divide each side by 4, it's the same as multiplying by 1/4. That's y equals negative 1/16 x. This is the one that's not direct variation. So this is direct variation, it's y equals kx. But this one, you're going to have a y-intercept of 4. It's not in the form of y equals kx. There's something else attached to it. That's that plus 4, meaning the y-intercept is not 0. It's actually 4. So correct answer for that is C. You can download a 5 megabyte file in 2 seconds. The time T it takes to download a file varies directly with the size S of the file. write an equation of direct variation to represent this situation, then how long will it take you to download a 3 megabyte file? We'll simply let t equal the time to download, and then s would be the size of the file. T varies directly with s, just like y varies directly with x. You could write this as t equals k times s. And we need to write an equation of direct variation to represent this situation. So the time t is 2 for a 5 megabyte file size. So put 2 in for t, 5 in for s. That will give you the constant of variation. K is equal to 2/5. If you want a decimal, you could change that to 0.4. So your constant of variation, you could say, is 2/5 or 0.4. To write an equation of direct variation that represents this situation, right there's your constant of variation. Time varies directly with size, so t is equal to 0.4s. That's your equation that represents this situation. The time it takes varies directly with the size. In this case, t equals 0.4s, where 0.4 is that constant of variation. Or if you divide the time by the size, it's going to be equal to that 0.4. So if you divide both sides by s here, t over s, the time divided by s is equal to 0.4. Last thing here, how long will it take you to download a 3 megabyte file? You can do this a couple ways. You could set up a proportion, or you could just use this, t equals 0.4s, and substitute 3 in for s, because 3 is the size of that file. So replace the s with 3, multiplied by 0.4. There's your time it takes to download a 3 megabyte file. T equals 1.2, in other words, 1.2 seconds it'll take. If y varies directly with x squared and y equals 2 when x is 4, so that part is given to you. There's no questioning that part. But the question or the mistake is here. Somebody says y equals 3 when x is 9. Y varies directly with x squared. It means y equals k times x squared. This is given. There's no arguing this first line. Y is 2 when x is 4. Put 2 in for y, 4 in for x. You have 2 equals 16k. The constant of variation is 2 over 16, or 1 over 8. If you divide each side by 16 here, k, the constant of variation, is 1/8. Now we're going to apply that to this. It says y is 3 when x is 9. We're going to prove that wrong. So y equals 1/8 times this 9 squared. So we're taking this y equals kx squared, substituting 1/8 in for k, and this 9 in for x. And that should be 3. Well, we're going to prove that wrong right here. It's 1/8 times 81. That is 81 over 8. So instead of it being 3, instead of y being 3 when x equals 9, y is really 81 over 8 when x is 9. Speed of 75 miles per hour is equal to a speed of 110 feet per second. To the nearest mile per hour, what is the speed of an aircraft traveling at a speed of 1,600 feet per second? So if it's going 1,600 feet per second, we want to find out what that is in miles per hour. But you know that 75 miles per hour is the same as 110 feet per second. You just set up a proportion. 75 miles per hour is to 110 feet per second, as the miles per hour we're looking for, x, is to 1,600 feet per second. This is the easiest way to do it. Just set up a proportion and cross multiply. Take 110 times x, that is 110x. Cross multiply the other way, 1,600 by 75, that is 120,000. And divide each side by 110. X, in other words, the miles per hour speed that's equal to this, is 1,090.909 miles per hour. Or in other words, it's asking you to the nearest mile per hour. 1,091 miles per hour is the same as 1,600 feet per second. We have 3 things to do here, A, B, and C, and then we're done. The length of an object's shadow varies directly with the height of the object. A 15-foot tree casts a 60-foot shadow. I'm going to say that S is a shadow length and H should be the height. So to write the function rule, the shadow varies directly with the height. Just like y varies directly with x, that's written as y equals k times x. This is written as s equals k times h. There's your function rule. Need to find the constant of variation. S is the shadow. I'm going to put 60 in for S. And H is the height. I'm going to put 15 in for H. So 60 equals K times H. This will give us that K, that constant of variation. Divide each side by 15. K, the constant of variation, is 4. So S equals KH. That's the function rule for the whole thing. 4 is the constant of variation. Now, it says, what length shadow would a 7-foot tree cast? You could set up a proportion here if you wanted to. Or you could just use this S equals KH. You know that K is 4, so 4 is going to go in for K. You're finding the shadow, you're finding S, and you know the height. So put 7 in for H, 4 in for K, and that will give you the shadow. It's 28. So a 7-foot tree will cast a 28-foot shadow. Finally, what tree height would cast a 90-foot long shadow? Well, again, you could use this S equals KH. You know that K is 4. No matter what you're finding, K is always going to be 4 in this situation. So put 4 in for K. You need to find the tree height. We're going to find H this time, given a 90-foot shadow. So put 90 in for S. Again, that 4 goes in for the constant of variation K. And we'll be finding the height. Divide each side by 4. There's the height of the tree with a 90-foot shadow, 22.5 feet tall, which happens to be 22 feet. How many inches? 6. 22.5 feet, 22 feet, 6 inches for that tree.